Hey, what's up, guys? My name is Saurav, and this is my YouTube channel, Data Science Novice. So, if you are new to my YouTube channel, please do like and subscribe. Your efforts are massively appreciated. So, in the last video, we talked about image thresholding, and in this video, we are going to talk about morphological operators. So, it is a very mathematically loaded section, and I have provided the link in the description for the mathematics behind each operation that we are going to perform. So here in this video, we are going to look at the practical aspect of morphological operators. So let's talk about morphological operators or transformations. So morphological transformations are some simple operation based on image shape. It is normally performed on binary image, and binary image is nothing but an image containing white and black pixels. So in a way, they are a set of kernels that can achieve variety of effects. So the most basic morphological operations are dilation and erosion. So dilation adds pixel to the boundaries of an image, while erosion removes the pixel of an boundary. So basically these are opposite of each other. And the number of pixels added or removed from the object in an image depend upon the size and the shape of structuring element that is based on kernel. So the size of kernel decide that how much pixel should be added or how much pixel should be removed from the our image. So these are the techniques we are going to talk about. So we are going to talk, we are going to see the practical application in Python of dilation, erosion, opening, closing, and gradient. So let's jump to the Jupyter notebook and see the practical application of these techniques. So here I am in my Jupyter notebook and I have already imported the libraries that we need, and I have created a plotting function which I have talked about in previous videos, that why we need this function. And I have also created a binary image, and this image has a black background with my name written on it in a white text. And I have already talked about this code in one of my videos, that is how to create shapes and memes, and I have provided the link into the description. You can check out that video. So let me run this cell and show you the image. So here you can see that the image has Saurav name on it and there is a black background. So this is a binary image. And now you can see that in my name, alphabet S and A are touching each other. And that is the case with alphabet U and R and A. So we will try to correct this thing using erosion. And to do that, first we have to create a kernel, and the size can be anything you want. So creating a variable kernel and then calling np.once and passing the kernel size. In this case, we are going to have a 5 by 5 kernel. So let's see this kernel first. So here you can see that it contains ones, and you can have any type of kernel you want. You can design any kernel you want. It's not mandatory to have a kernel like this. Next, we are going to use erosion in order to correct the image. So erosion is nothing, just we try to remove some pixel from the image. So first we are going to create a erode variable to store the output of the transformation. Next we call cv2.erode and then we pass few parameter like image on which we want to perform the erosion. Next we pass the kernel that we created earlier, and then the iteration, that the number of time we want kernel or filter to pass over the image. In this case we are going to pass 1. And next we plot the transformed image using image plot function and we pass the erode variable in it. So now let's run this cell. So here you can see earlier alphabet S and A were quite merged in. And now you can see it is less than the original image. And that is the case with alphabet R and A as well. So next we change the iteration to 3 and rerun the cell. So now we can see that alphabet S and A are disjoint. And similarly we can see the alphabet U, R and A are less connected. And we can compare it with actual image. So you can see here that we have eroded so many pixels from the image. So now let's see the extreme effect. So we pass the iteration equals to 5 and rerun this cell. So now you can see that letter S is almost diminished and so does the other letters. So let me make it to 3. So now you can see that this way we can separate text using erosion if they are mixed together. So next we have dilation. So as we talked about it earlier, the dilation is nothing, just opposite of erosion. So in dilation, what we do, we add another extra pixels to the image. So let's create a dilation variable and then we call cv2.dilate And again, it takes same parameter as erosion. So we pass the image, then kernel, and then we pass the number of iteration. Next, we call our image plot function, and then we pass the dilated image, that is dilation variable in it. So let's run this cell. Okay, so here we are getting error. So let me correct the spelling of iteration, and we will rerun this cell. And here we can see that alphabet have mixed up. If we compare it with the original image, the alphabet A is so mixed up that we cannot see it properly. It just look like filled inverted V. So if we were to have this image, we could have used dilation to get the original image. So this way we can use dilation. So next we try opening and closing. And for that I have provided the two images, one containing background noise and one containing foreground red noise in the description. So let's talk about opening first. So what is opening? So opening is nothing but erosion followed by the dilation. And this operation is good with removing background noise from the image. So let's import the image first. So I'm going to store the image in a variable called noisy image. And we read it as a grayscale image. So we pass 0 for that. So now let's plot this image. And next we call our image plot function and pass the noisy image. So let's run this cell. So now we can see that this image contain a lots of noise. So now we will try to remove the noise using opening and see how it looks like after removing the noise. So let's create an opening variable and then we call cv2.morphologyx and then we pass few parameter. So the first parameter is noisy image itself. Next we pass the method. So calling cv2.morph and press tab to see the methods available. So these are the method available to us. So next we choose open. Next we pass the kernel that we created earlier. So now plot the transform image. So calling image plot and passing the opening variable. So let's run this cell. And now we see that all the background noise has been removed from the image. And this image somewhat looks like the original image. So our opening help us removing these kind of noise from the image. And mostly this is used when we try to extract text from an image because then we have to deal with a lots of noise that we talked about in thresholding as well. So opening is used when we have background noise. But what should we do when we have foreground noise? So for that we use closing, and closing is nothing just opposite of opening. So in closing what we do dilation followed by erosion. So let's do that. So first we import the image containing foreground noise and I have already provided that link into the description so you can download from there. So we again read image as a grayscale image and for that we just have to pass 0. So now let's see the image that how it looks like, how the foreground noise looks like. So we use our image plot function. So let's run this cell. So here you can see that this is how foreground noise looks like. So now our target is to clean this image. So this image looks similar to the image we created in the starting of this video. So first we create the closing variable and the code is going to be very similar to that of opening. So we just have to change the method to closing and the rest of the parameters are going to be the same. So calling cv2.morphologyx and then passing noisy image and then we pass the method. So in this case we are going to use closing and then we pass the kernel that we created earlier. So now let's plot the image to see the result. So here we can see that we are able to clean the image. Earlier we had a grainy noise over my name. Now it has been clear, that is we are able to clear the foreground noise from the image. And this image looks very identical to the original image we created. So this way we can make use of closing to achieve this kind of effect. So next we are going to talk about morphological gradient. So a morphological gradient is the difference between dilation and erosion of a given image. So this is used in edge detection, segmentation and to find the outline of an object. So let's create a gradient variable and then we call cv2.morphologyx and then we pass few parameters. So we pass the original image we created in the beginning of the lecture and next we call cv2.morph and press tab. So and we can see that gradient method and then we pass the kernel and next we call our image plot function and then we pass the gradient and let's run this cell. So here we can see that the image kind of looks shallow as if we have removed the pixel from this image. And this help in edge detection, and we will talk about it how it helps in edge detection in the edge detection lecture. And so this way we can achieve gradient. Now we will try to do it manually. As we have our dilation and erosion variables, so we create a new image variable and then we perform simple mathematical operation, that is dilation minus erosion. So let's plot this image and see how it looks like. It should somewhat looks like this gradient image. May not be perfect, but it should somewhat looks like that. So this does not look identical to the gradient, but somewhat similar to the gradient image. So this way you can try opening closing as well. I encourage you to do that. So that's all for this video. If you are new to my YouTube channel, please do like and subscribe and press the bell icon for the future updates. So see you in the next video. Till then, bye, wear mask and stay safe.